Hello, Ishan.
Good evening, sir.
Good evening. So I hope I am audible to you clearly.
Yes, sir. You're audible.
Okay. So Ishan, in the last class we had done about the kinematic equations of motion.
Yes,
I
sir.
will continue. I will try to continue with a few questions from those kinematic equations of motion.
Okay, sir.
Right. So let us try to do a few questions from that. Kinematic equations.
Sir, I wrote my physics exam well, sir.
Okay. So was it good? Were you
Yes, sir.
able to solve? Okay. Were you able to solve out the kinematic equations?
Sir, yes, sir. I practiced, sir, on that day.
Okay.
Yes, sir.
Like just I'm sharing this question. ठीक है, ठीक, ये भी पहला। अभी so let me share the screen now.
Sir, you want me to share my college material, sir?
Uh, if you can, if you would share it, then it would be good for you also and for me also, as I
Yes,
would
sir.
be clearly aware that what is going on in your college. Okay.
Yes, sir.
Otherwise, I have my materials also, so accordingly, I will stick to it.
Okay, sir. Sir, I'll send you in WhatsApp, sir, to you personally.
Okay. Nice.
Yes.
So this question I'm talking of question number 21 is here. A ball is projected vertically upward with a speed of 4 meter per second from a point 64 meter above the ground. Find the time it takes to reach the ground. Okay. So see, we will try different aspects. We'll try to solve this out with a number of methods. So here you have a building. I hope
Yes,
the
sir.
screen is visible to you. So
Yes, sir.
the building is 64 meter tall. Okay. So this building is 64 meter tall. And if I throw something above it, so I want to throw something, a ball is projected vertically upward from here, like this, with an initial speed of 4 meter per second. Okay.
Yes,
It's
sir.
4 meter per second. That's the initial speed. U is 4 meter per second. And you have to tell that how much time will it take to reach the ground. So when it hits the ground back, as you know that the ball will go up to a certain height, and then from there it will again start falling back.
Yes,
Okay.
sir.
So you have to tell that how much time will it take for the ball to reach the ground. You have to take the acceleration due to gravity is given out to be 10 meter per second.
Okay, sir.
So, see, there are different methods which can be used. For example, the method that we have studied in earlier classes, like this, uh, I can consider here, I can consider the motion of this ball in two parts. Okay. Like one of the first part is when the ball moves from here and reaches the top. So when it reaches the top, it has its final velocity equal to 0.
Yes, sir. 0.
Okay. So
Yes, sir.
I will find out the time taken by the ball to reach this height. Okay. Then I will try to find the time that it will take to fall down to the ground.
Okay, sir.
So for this situation, what are the things that I will in the sense the ball is moving upward. So I'll be taking the initial velocity to 4 meter per second upward. And since acceleration due to gravity is acting downward, so this I will be taking as negative. I'll be taking as negative g or negative 10 meter per second. So by using the formula of v equals to u plus at, I will be able to find out the time. Since I know the final velocity that it has is 0,
0.
the
Yes, sir.
initial
0.
velocity with which it was
4.
shown is 4, plus
Yes, sir.
acceleration is negative 10. and
Right.
multiplied with t.
Yes, sir.
So I get t equals to 0.4 second, right?
Yes, sir.
Now I'll find out the time taken by it to reach the ground. Now, as of now, I don't know the final velocity with which it will hit the ground. Now, for this, whatever was the final velocity here, 0, this would now become the initial velocity. For this part of the journey, it would become the initial velocity, and hence the initial velocity of this will be equal to 0. Okay.
Yes, sir.
And acceleration, I'm aware, but I don't know the final velocity. So I must know the displacement that it has to travel. So for the displacement that it has to travel, I will also need to find out the distance that it has gone from this building to this point, and that displacement can be obtained by the formula S equals to ut plus half at squared, or I can use v squared minus v squared equals 2as. So both of them will give me the displacement. So if I
Yes,
use
sir.
v squared minus u squared equals to 2as, just hold on for 1 minute. Okay, Rohan. Okay, Ishan, I'm back.
Yes, sir.
So,
Sir, I
see,
have sent you,
so
sir. Sir.
okay, I'll check it.
Okay,
Yes,
sir.
you have sent.
Yes, sir.
So for this
Mostly
one,
I
I
sent, sir.
I get v is equal to 0 minus u is 4 squared equals to 2 multiply acceleration, that is negative 10, and hence s. So it's negative 16 divided by negative 20 makes it s.
Yes,
So
sir.
positive. It becomes 4 by 10, so that's 0.4
Okay.
meter.
Yes, sir.
Okay. So the ball goes upward with this to a displacement of 0.4 meter only, and it has to travel a total displacement of 64.4, right?
Yes, sir.
So I get here my total displacement as 64.4. Now I can find out the time taken by using the formula S equals to ut plus half at squared. I can use that to find out the time taken, or even I can use the formula v squared minus u squared equals 2as to find the final velocity, and then use the first equation.
Okay, sir. Got it.
So either one I can use. So let's try to use the second one. I have S equals to ut plus 1 by 2 at squared. Displacement is 64.4 meter. Initial velocity is 0.
Zero.
Multiply
Yes.
time. That is t
T
plus
square. Yes.
1 by 2 multiply acceleration is 10 multiply t square. So this becomes 0. You get 64.4 multiply 2 divided by 10 makes it t squared. So you have now 12.88 as t squared. So your t will be equal to square root of this.
Yes, sir.
Square root of 12.8. So you can find the square root of 12.88 would be equal to square root of 1288 divided by square root of 100.
Yes, sir.
So I find square root of 1288.
Okay,
That
sir.
is 35.8.
Yes, sir. 35.8.
So 35.8 divided by 10, that makes it 3.58 seconds. So you can say 3.6 seconds will be the time taken by the ball to reach the ground from the top point. So from this top point, the ball reaches the ground over here. The initial time was 0.4. So if I add 0.4 and 3.6, I get a time of 4 seconds. Okay. So total time would be 3.6 plus 0.4.
Yes, sir. 4.
Got it? That's 4 seconds.
Yes.
Okay.
Yes, sir. Sir, let me write that one, sir.
Which one?
The question, sir. Before slide.
Okay.
Yes, sir.
So I hope you have understood. First, we have found out the time taken for the ball to reach the highest point, and then we found out the time that it will take to fall from this point to the ground, right? And this time we got as 3.6. The earlier time was 0.4. We added both of them, and we got the answer as 4 seconds, right?
Yes, sir.
Now see the other method. This was the previous method which we generally do in class 9. If we apply class 11th concepts, and let us try to do the same question.
Okay,
So
sir.
as per class 11th, again the given things are same. We have again a building, and from the top of the building you throw a ball. So the height of the building is still 64 meter, and this is the initial velocity. So here our initial velocity is taken to be 4 meter per second. The ball is moving upward and it has an acceleration downward. Acceleration is given as 10 meter per second, right?
Yes, sir.
Okay. So we first take our coordinates. We take the coordinate system. So in the coordinate system, to describe this motion, we take the upward direction to be the positive direction and the downward direction to be the negative direction. Okay.
Yes, sir.
And let this building be the topmost point. Okay. Let this be the origin. So since building is the origin, so from this point, I'm considering the vertically upward direction to be the positive direction and vertically downward direction to be the negative direction.
Yes, sir.
Okay. So from this, I will get my initial velocity as plus 4 meter per second. My acceleration to be equal to negative 10 meter per second square. Okay. And the displacement will be equal to negative 64 meter. Since the displacement is downward. Okay.
Yes, sir.
So I want to find out the displacement as negative 64 meter. Now
Okay, sir.
I will apply the equation, second equation of motion. So I know S equals to ut plus 1 by 2 at square. So our initial velocity here is 4 multiplied t.
Sir, S is equals to minus 64, sir.
Yeah, so S is minus 64. We'll put here minus 64. Will
Yes,
be
sir.
equal to 4 multiplied t plus 1 by 2 multiply acceleration, that is 10 multiplied t square. This makes it 5. So you get minus 64 equals to 4t plus 5t squared. Here we get a quadratic equation,
Yes, sir.
and this quadratic equation is 5t squared plus 4t
Plus 64.
minus plus 64
Yes,
equals to 0.
yes, sir.
I will try to solve out this quadratic equation.
Yes.
So
By
using
taking-
find
Yeah.
d, try to solve it out using the discriminant method.
Okay, sir.
Okay, so are you able to get it?
Yes, sir. I'm doing, sir.
Okay. Okay, acceleration is also negative. Just one error has we have taken up. Since acceleration is also downward, so we must take acceleration also as negative. Okay. So this must be taken as negative. Here it should be just make a correction here. Here it should be getting negative 5t square. So yeah, it has to be negative 5t square. So just
Okay,
make a
sir.
correction. Since
Yes, sir.
acceleration is negative, it's in the downward direction. So it has to be taken as negative. We have to take negative 5t square. So then you can move on to find out t. So 1296.
Yes, sir.
And if you find square root of 1296,
Sir, 36, sir.
36, right?
Yes,
So
sir.
now we can find out t to be minus b, that is minus 4 plus minus 36 over 2a. It's 2 times 5. So you get minus 4 minus 36 divided by minus 10. So answer is minus 4 seconds, right?
Yes, sir.
So plus 4 seconds. Minus minus cancel up, you have plus 4 seconds. Another one you can get if you consider 36 as positive. So if you consider 36 as positive, you get 36 minus 4. That would be 4. That would be 32. 32 over 10. That would be 3.27.
Yes,
Got
sir.
it?
Yes, sir.
So here two possible solutions have been shown since a quadratic equation. So all quadratic equations have two solutions. So here in the previous one also we got the answer as 4 seconds.
Yes, sir. 4 seconds.
Here also we got the answer as 4 seconds, right? So see, this is your method of class 11. By considering the coordinates, you can find the answer.
Yes, sir.
So let's try to do a few more questions based on these equations, and then we'll move to instantaneous velocities, instantaneous and average velocity. Okay, let's try to do these two, and then I'll tell you the displacement in nth second. Let's see this one. Try to do this 9-1. And it will be done with the method. You can try the method of class 11.
Yes, sir.
Okay, so are you able to think about it in the similar way? It will be done.
Yes, sir.
Okay. So you know the initial velocity, you know the final velocity, you know the Okay, so shall I help you out?
Oh, yes, sir.
Okay. So let's consider the situation that are given here. Again, you have your top of a tower, and from this tower you are projecting a ball, and this ball is moving upward. So this ball is moving upward with a certain, it has been thrown upward with a velocity v. So its initial velocity is v, and when this ball hits the ground, so it hits the ground with a velocity 3v, but this velocity is in the downward direction.
Yes,
So
sir.
if I consider this velocity to be positive, so this
Negative.
velocity has to be negative.
Yes, sir.
The displacement over here is the height of the building,
Yes, sir.
height of the tower, that h.
H.
And I know the acceleration due to gravity over here is given as 9.8.
9. Okay, sir.
Uh, okay, let's take it g, and then we'll see if we put 9.8 or 10. Okay, since 9.8 is given in the second part, so we'll see what can be put over there. Now, use the equation.
Sir,
We
it's
can use
plus.
the equation v squared minus u squared equals to 2as, right? Here
Sir,
acceleration is negative since it is
sir,
downward. Yes,
sir, it's plus or minus U, sir.
it's
Sir, it's acceleration is negative or positive, sir.
acceleration is negative since it acceleration is acting downward.
Okay,
Okay?
sir.
And we have taken the vertically upward direction to be the positive direction.
Yes,
If
sir.
we take the however, we can consider it like this also. We can consider it like the downward direction also we can consider to be the positive direction, and upward direction to be the negative direction, right? If we consider like this, then our this initial velocity will be negative, and acceleration and final velocity will become positive.
Yes, sir.
Okay. So first let's try to do by what we had assumed earlier, and then we'll try to apply this method also.
Okay, sir.
So here if I do this, I have put v as negative 3, so put negative 3v whole squared minus initial velocity u, which is v squared, should be equal to 2 multiply a, that is 9.8, and multiply s. A is negative 9.8. So this is 9v squared
Yes,
minus
sir.
v squared to
Sir.
be equal to negative 19.6. Am I right?
Yes, sir. 90 into S.
And what about the displacement? Should the displacement be positive or negative?
Sir, it's negative, sir.
Yeah. So I have to take this s also as negative. So I put
Yes, sir.
negative 19.6 multiply negative s. So negative and negative will cancel. Here you have 8v squared to be equal to plus 19.6 multiply s.
Yes, sir.
Okay. So in terms of v, I can obtain this displacement. Displacement would be 8v squared over 19.6.
Yes, sir. Got it.
Got it?
Yes, sir.
And okay, I think this is what we can have. We can't have the absolute value. Let's see if we can, let's try to have absolute value also, if it's possible. Okay, let's try v equals to u plus at and try to find out t also so that we can get the absolute value. So our final velocity was negative 3v would be equal to u, which is v plus a, that's 9.8 multiplied t. Okay. So you have 4v, negative 4v equals to negative 9.8 t. So t also we are obtaining in terms of v also. Okay, so yeah, this is what you will get. Your displacement is, or the height of the building is 8v squared over 19.6.
Okay.
Okay. Got this? Now try the second one.
Okay, sir.
A stone is thrown vertically upward with a velocity of 19.6 meter per second. After 2 seconds, another stone is thrown upward with a velocity of 9.8 meter per second. When and where these two stones will collide? Okay, so are you able to think about this? How to move to this solution?
Yes, sir. I did it, sir.
Okay, so what is the time?
I'm doing it, sir.
Okay.
Sir, I'm getting 0, sir.
Okay, you are getting 0. Okay, there will be one more solution. Try out. There are two solutions possible for it. You must be getting a quadratic equation. And remember, a quadratic equation has two solutions. Are you getting only one solution?
Yes, sir.
Okay, let's see. Okay, maybe it's correct. Let's check it out. I think you are correct. So your first stone that is thrown upward, and it is thrown upward with a speed of initial velocity of 19.6 meter per second. And after 2 seconds, another one is thrown. Okay. So from here,
Yes.
another one is thrown upward with a velocity of 9.8 meter per second. So when and where they will collide. So first of all, I will check that how long will it go? Will the first one take to reach the maximum height? So when the first one reaches the maximum height, its final velocity will be equal to 0.
0. Yes, sir.
And I get v equals to u plus at. So my v is
0.
so you put here it's 19.6 meter per second, right? So put the values. V is 0 equals to u, that's 19.6 plus acceleration. Since acceleration is downward, so it will be negative. You put negative 9.8 multiplied t. So see, this one becomes negative 19.6 divided by negative 9.8 equals to t, and hence you get 2 seconds, right?
Yes, sir.
So now at this point, this is at the highest point and this is at the lowest point. Okay. Now, when it is at the highest point, that is the time 2 seconds, and then it comes down.
Yes, sir.
So now we need to find out when will they collide with each other. So now it becomes a separate case here. Create a separate case for it, something like this. And I will try to do this with your grade 11th method also. Okay, what will be your method for class 11th? So
Okay,
here,
sir.
this one is coming down, this one is going up like this. So you have this ball going up with an initial velocity of 9.8 meter per second, and this one coming down with a speed of 9, its initial velocity being 0. So here initial velocity being 0. Here the acceleration A is negative 9.8, and here, sorry, here acceleration will consider as positive. If both of them are moving in the same direction, so here we'll consider the acceleration to be positive, and here we'll consider acceleration to be negative, A as negative. So for this one, let us say both these objects, they meet at a after a time t. So after a time t, both of them meet each other. So I'll find its. So how do I find t now?
Sir, by S is equals to ut plus half at square, sir.
Okay. So I don't know s.
Sir?
I don't know s. So s I need to find out from this one.
Yes, sir.
Okay. So from here you find out s, then you will be able to get the time, get the displacement. And suppose they meet at a certain point x over here at a height x. So this would become x and this would become the displacement minus x, right? And then we can move on. Okay.
Yes, sir.
Okay, Ishan. So we'll see in next class. We'll try to solve it out in the next class, right?
Sir, will you share this one, sir?
Yeah, I'll share this to the group.
Okay,
Okay,
sir.
bye, Ishan. Bye. And